Okay, so here is a problem for a capacitance distinction. In this problem, we have two small irregular shaped conducting objects, one carrying a positive Q charge and the other carrying a negative Q charge, which are placed on a x-axis, one being x equals negative 4 meters and then the other x equals 4 meters, respectively. And then there's an electric flux between which you're given this equation, Ex equals AQ times x squared plus b. And it tells us in the problem that A and Q are constants, and it wants us to find the units of A. And so I did that by doing, first I just wrote the equation that was given, and I know that Q is the magnitude, the charge magnitude, and X is the distance of the charges, as stated above. And then what we're going to do is find A. So what I did was I did A equals EX divided by Q times x squared plus b. And then I obviously know an electric field is always newtons per coulomb. And then Q is going to be coulombs. And then x squared is going to be meters, as shown in the problem, squared. So then you get A equals newtons divided by coulombs squared times meters squared. And then the second part of the problem was it wanted us to find the capacitance. And so what I did was first, I know that V equals the integral of EX dx. And so I did V equals negative 4 to 4. So let's go back actually. So capacitance is Q divided by V, which we don't know V, and so that is why I'm deriving it from this. And so AQ x squared plus B dx, and then AQ is going to be times, when you integrate that, it's going to be x cubed divided by 3 for this x squared plus bx, because b, so it's just going to be bx. And so then we can integrate that, plugging in the negative 4 and 4 into x. And so we're going to get, first we're going to do 64, so because it's 4 cubed, which is 64 meters cubed, divided by 3, plus b, and then x was 4 meters. And then we're going to, AQ comes outside because it's a constant, so we don't know what it is, so it's actually, this whole thing should be bracketed off, as in AQ is multiplied by this entirety, by this entire thing. And so then we have negative 64 meters cubed, because negative 4 cubed is going to get you a negative. And so that's subtracted, so we know that we're actually going to get a big plus sign here. So it's actually going to be added in the end. And so we have 64 meters cubed divided by 3 plus negative 4 meters b times b. And so then we can simplify that by, so 4 minus 4 is just nothing. Oh wait, 4, because we had a negative. Oh yeah, so this is actually going to be positive too. So 4 plus 4 is 8, and then 64 plus 64 is 128. So simplifying that, we get AQ is 128 meters cubed divided by 3 plus 8 meters times B. And then now that we know what V is, this is V, we can plug this in to our equation for C, for the capacitance, which is C equals QV. And so Q divided by plugging V in, we get AQ times 128 meters cubed divided by 3 plus 8 meters times B. And then Q and Q cancel out, and you're just going to get 1. So you get 1 divided by A 128 meters cubed divided by 3 plus 8 meters times b, and that is your capacitance. So here we go. This is one of the 3 stars on the MyLab, or not the MyLab, but the textbook. The questions in the practice questions in the back of the book. Okay.